Welcome to Mr. Chalk's Revision Tips. In this video, we will look at redshift, the Doppler effect, and emission spectrum. The Doppler effect is the change only in the observed frequency of a source which is stationary relative to an observer. Both the frequency and the wavelength change when a source is moving relative to an observer. You can hear this effect to yourself by listening carefully to traffic as it goes by you on a main road. So the Doppler effect means that sound moving away from the observer appears to be at a lower frequency. The same thing happens with light from distant galaxies, which appears to be shifted towards the low frequency end of the spectra, which is the red end. So this means that distant galaxies moving away from the Earth appear more red. It has also been observed that the further away a galaxy is, the greater amount of redshift there will be. So this means that very distant galaxies must be moving away from us faster than closer ones. Redshift is a key concept for astronomers. The term can be understood literally as the wavelength of the light is stretched, so the light is shifted towards the red part of the spectrum. Something similar happens to sound waves like we've just discussed. So scientists examining light emitted by stars observe dark lines in the spectrum. These dark lines are caused by different elements such as helium in the stars being studied. Erwin Hubble observed that the pattern of dark lines in light from distant galaxies is shifted towards the red end of the spectrum. This red shift suggests that distant galaxies are moving away from the Earth and supports the idea of an expanding universe. So redshift occurs because of the Doppler effect, which can be observed in all forms of electromagnetic waves. Light from a star does not contain all the wavelengths of the electromagnetic spectrum. Elements in the star absorb some of the emitted wavelengths, so dark lines are present when the spectrum is analysed. Different elements produce different patterns of dark lines, so the diagram shows part of the emission spectra of light from the sun. So astronomers can observe light from distant galaxies. When they do this, they see that they're different to light from our sun. So the dark lines in the spectrum from distant galaxies show that they've increased in wavelength. The lines are moved or shifted towards the red end of the spectrum, which is why we call it redshift. So this diagram shows that there are more lines towards the red end of the spectrum. So the light has been shifted towards the red end, or the wavelengths have been stretched. Astronomers see redshift in virtually all galaxies. It is a result of the space between the Earth and the galaxies expanding. This expansion stretches out the light waves during their journey, shifting them towards the red end of the spectrum. So the more redshifted the light is from a galaxy, the faster the galaxy is moving away from the Earth. So if we look at this question, so redshift gives evidence of the Big Bang Theory. Explain how the observation supports the Big Bang Theory and the formation of the universe. Key things to talk about are that the furthest galaxies show the biggest redshift, meaning that the furthest galaxies are moving faster. So the universe must be expanding. And if we go and extrapolate that back, it means that the universe back in time would have condensed and would have initially started at a single point.
Thanks for watching.